Fission Mobile, quality e-learning experience on the go.
What is an atom? The word atom actually comes from the Greek word atoma, which actually means indivisible. So in 1808, John Dalton made a proposal of the atomic theory. He suggested this proposal contained 5 separate lines of words. In first one says that atoms are made up of small indivisible particles, which are called atoms. All elements are made up of small indivisible particles called atoms. Second one said atoms can neither be created nor destroyed. The third one said that atoms of the same elements are alike in every aspect and differ from those of others in every aspect. And fourth one says when atoms combine with each other, they do so in small ratios. Last says all chemical changes result from combination or separation of atoms. But unfortunately, Mr. Dalton has been proved wrong in practically all of his theory. Some of them. Yeah, in 1898, Mr. Joseph John Thomson, that's J.J. Thomson, he made a discovery that the so-called atom that was indivisible contained a particle that has a charge, and this particle was named the electron. And in 1910, R.A. Millikan was able to successfully measure the quantity of charge in an electron to be minus 1.6 times 10 raised to the power minus 19. In 1910, Rutherford oversaw the works of Ginger and Menu, and that led to the discovery that the atom actually had a core, that is, it has a nucleus, and it also has the outer part. So that led us to another new discovery which continued the quest for knowledge. And in 1913, of course, Neil Bohr, one of the students who had worked on what Rutherford had worked on, he suggested that the electrons were not just hanging around about the core of the atom, but they were actually in orbits, just like the planetary bodies are about the sun. So they are actually in orbit. In 1914, Moseley discovered that it could actually assign numbers to each of the atoms, each of the elements, one after the other, and that was where the introduction of the atomic number came about. In 1932, Chadwick bombarded beryllium sheets with alpha particle, and then a new substance was discovered, and it was called the neutron. From there we knew, the atom contains 3 different components: the proton, the neutron, and the electron. Up on the slide there we have the atomic number, we have the helium element, the element helium being displayed. Helium has 2 protons in its atom. The atomic number is actually the number of protons in elements, and the atomic mass, that's the sum, that's the number of protons and neutrons in the atom, in nucleus of a particular element. Our electron carries negative charge but has no mass. Our proton carries a positive charge, has a mass of 1, a relative mass of 1, while our neutron carries no charge and has a relative mass of 1 as well. Isotopy. The concept of isotopy is also another thing which was proved wrong in a statement of Mr. Dalton. He said elements of a particular atoms of a particular element have everything in common, but isotopy actually proves to us that that is not true. It is possible for us to have, there are actually isotopes. Isotopy is a state in which you have a particular element having more than one type, that is having varying mass numbers. It's the varying mass numbers is actually due to the presence of more or less neutrons in the nucleus of the particular atom. For example, taking the chlorine atom, there is a chlorine atom that is chlorine 35 and there is a chlorine 37. So how do we go about to calculate the mass number when we are given this particular varying isotopes? Oh, very easy. All we just need to do is multiply by the percentage, calculate the percentage and multiply it to the mass number of that particular isotope, then sum them together as done in the example being displayed on the slide. Electronic configuration. Let's talk about the electronic structure of atoms. Electrons, of course, exist in levels due to the shells in which they orbit around the nucleus of the atom. And the first shell contains 2 electrons, second shell contains 8 electrons, the third shell contains a maximum of 8 electrons. But there are 2 basic ways of representing this atomic structure diagrammatically. We have the electronic configuration method, and we also have the dot and cross diagrams. In the electronic configuration method, we simply write out the numbers according to the shell, just as we have on the screen. Nitrogen has a mass number, an atomic number of 7, which means the first 2 elements and the first 2 electrons would be in the innermost shell, which is K, and that shell only holds 2 electrons, while the next shell, which could hold as many as 8 electrons, since there's just about 5 electrons left, to just accommodate all the rest. So it is represented in the configuration, it will be 2 and 5. How about the dot cross method? Dot cross method is being displayed on the screen now. It's just about you drawing it and making it more visually and making it more visual, making it more real, making it more in an apparent way to us. The periodic table. The periodic table is simply a table that contains rows and columns in which elements are written according to the properties which they possess. The periodic table can be classified into 2 parts. So we have the rows, which contains the periods, the horizontals, that's the periods, and we have periods varying from 1 to 7, and we also have the groups. The groups are also varying from 0 to 7. And the period actually shows us the number of shells which the particular element has, while the group number actually shows us the number of electrons that exist in the outermost layer of the element of the atom. There, we have the periodic table. Periodicity of elements. Basically, what do we mean by the periodicity of elements? Simply talks about the reoccurrence. What are those things that are happening over and over? Of course, the periodic table is arranged in such a way that we will be able to identify certain things, that these particular properties are particular to this class of things, this group of items. So what are those things that are particular to each of them? So that's what periodicity of the elements actually talk about. Now, talking about periodicity of elements, we have several things in which elements have in common, like how the atomic size grows and contracts and all. But very, very important, there are 4 particular features which we'll mention and we'll talk about briefly. The first of them is the melting and boiling point. The melting and boiling point of the elements actually increase from left to right up to the group 4, that's up to the 4th group, and then it drops drastically because the non-metals, most of them are in gaseous forms, and when they are even in solid forms, they cannot absorb heat, they cannot withstand heat like the metals can. Electrical and thermal conductivity. Of course, electrical and thermal conductivity decreases across the table because metals are known to conduct electricity and heat properly as compared to the non-metals, and metals particularly find themselves on the left hand side of the table. So as we move towards the right hand side, the properties of conductivity reduces. But yes, ionization energy. Ionization energy is the amount of energy required to remove a valence electron from the outermost layer, the outermost orbit of the atom. Ionization energy reduces from left to right, but increases down the group. Electron affinity is just the opposite of ionization energy. Electron affinity talks about the love and passion to get an electron, to have one extra electron added to the list of electrons they already possess. Now, electron affinity increases across the table but decreases down the group, thereby making fluorine the element with the highest electron affinity. Electronegativity also reduces down the group and increases across the period. Each of the groups in the periodic table, group 1 elements are very stable. They are known as the alkali metals. They have one electron in their outermost shell, that is one valence electron that they really desire to lose. Because of their willingness to dispose of this one electron, they are very, very, very reactant. The group 2 elements, they are less reactive because they have 2 electrons. Losing one electron is tough enough. Losing the second one can be very, very difficult. So because of that, they are less reactive compared to the group 1 elements. They are known as the alkali earth metals. We have calcium, we have magnesium, we have some other elements like that. Group 3 elements, they are potential donors of 3 electrons. That is, whenever they have the opportunity of dumping all their 3 electrons, they would gladly do that. Well, they do produce both normal salts and complex salts when they react with acids and alkaline. Takes us to group 4 elements. 4 elements containing carbon, silicon, germanium, tin, and lead. They are tetravalent. In other words, they have 4 electrons in their outermost shell. They tend to form covalent bonds, and their property tends to change from non-metallic to metallic down the group. Group 5 elements containing nitrogen, phosphorus. These ones are very, very good acceptors of electrons. Group 6 elements, where oxygen and sulfur find themselves located, are naturally oxidizing agents. Group 7 elements are also known as the halogens. These have 7 electrons in the outermost shell, and because of that, they just need 1 electron to become stable. So they are very, very reactant. The name halogens actually come from, it actually means salt formers. Transition metals. Transition metals are located between the group 2 and the group 3 of the periodic table, and they are all metals. Yes, they have varying valences. One of the things about them, and their ions are actually colored. Yeah, and that takes us to the lichtenides. They are very, very rare earth metals. They are located in the 6th period, and beginning with lanthanum, ending with ruthenium. They show a great resemblance with one another. The actiniums are elements, and they look very much like the lanthanums in many ways, but they are located in the 7th period. They start with actinium and finish with uranium. These elements none of them exist naturally in nature. Chemical bonds. No chemical change can occur without a chemical bond being created. But now that takes us to the types of chemical bonds. We have two basic chemical bonds: the electrovalent bond or the ionic bond, and the covalent bond. Electrovalent bond. It's a bond that is being formed when an atom loses an electron or more electrons to another atom. Now, this usually occurs between elements like sodium and chlorine, where sodium can actually dash out one electron to chlorine, so it can attain its own stability, and chlorine also can attain its own stability. Now, once these two gain their individual stabilities, they become ionic, because the sodium is now lost one electron and it has become positive. It's now in its ionic state, and the chlorine also has gained an electron and it's become ionic. So that's why it is also called the ionic bond. Now, the loss and gain of this electron ensure that whatever new product is going to be made through them will be joined together correctly. Why is this joining together coming up? Because the positive and the negative forces would be attracting themselves, and they will try to crush into each other, even to make the atom even more compressed, or the molecules rather. Covalent bonds. In covalent bonds, unlike electrovalent bonds, where an atom is actually lost to the other an electron is lost to another element. In covalent bond, the element is not lost; it is just being shared. The two reactants would share one, two, or more elements together, and we have a very good example. We have two good examples in our slide here: the hydrogen atom with another hydrogen atom, and they join together and they share those two atoms. We also have that one of chlorine atoms. Two chlorine atoms coming together to form the chlorine molecule. Yes, what the properties of covalent bonds are: they have definite shape, they are usually gases or volatile liquids, they are electrically neutral as against the ionic bonds, they usually have low boiling points, with exception of some like dative bonds, like covalent bonds. Of course, they are very much alike. Very many of their properties are the same. The only slight difference is that they do not share the same number of electrons together with any of the elements. They either collect from one element or collect from other elements at the same time, and they are less volatile. They are less volatile because of the coordinate bond that exists between them. Yeah, other kinds of binding forces we have include the metallic bond, which is the bond that exists between two metals, the atoms of metals. The van der Waals forces, the forces that exist that causes the liquefaction of gases, and the hydrogen bond, which is a unique bond that is accustomed to hydrogen when it is interacting with another element, which happens to make a covalent reaction with it, trying to form a covalent bond with it. Yeah, we have different shapes in which our covalent bonds could come in. We have three major shapes: the linear shape, the trigonal planar shape, and the tetrahedral shape. The linear shape is like a straight line. It's the atoms are at 180 from each other. The trigonal planar, like a V shape, and the atoms are at 120 degrees from each other, while in the tetrahedra it's taking a tetrahedral shape, and the atoms are actually at 109.5 degrees from one another. Radioactivity. Radioactivity is the spontaneous emission of radiation by an element, and any element that does give out radiations is always known as a radioactive element. There are some basic things that you need to know about radioactivity. Radioactive substances emit emissions. They emit radiations constantly and spontaneously. Temperature and pressure have no effect on rate of radiation. Unlike light, radiations penetrate through opaque objects. They ionize gases that they pass through, and also have photographic effect. And at the same time, radiations are also associated with the release of energy, the nuclear energy. What are the particles? What are the types of radiations we have? We have the alpha particle. Alpha particle is like the helium nuclei. It has a mass of 4, a relative mass of 4, and because of its mass and because of its charge, it is positively charged. Because of the positive charge, it is slightly deflectable with a magnet. Slightly deflectable with a magnet, or with a magnetic field or an electrical field. The beta particles are fast moving electrons. They have weaker ionizing power compared to the alpha particles, and they are smaller masses. Due to their smaller masses, they are easily deflected by magnetic fields or electric fields, while the gamma rays have they are not affected by either electric or magnetic fields, because they actually do not possess any charge whatsoever. The half-life of a radioactive element is the time it takes that a radioactive element to disintegrate or decay half of the atoms in it.
In its.
Yes, that's the thing. Nuclear fission is the process. The nucleus of a heavier element is split into two, usually equal or close to each other parts, and it is always accompanied with the release of electricity, with the release of energy and radiation. Nuclear fusion, not fusion now, fusion is when we have two light nuclei coming together, fusing together to produce a heavier nucleus, and also it comes along with the release of energy and radiation.
Fission Mobile, quality e-learning experience on the go.